Hey, everybody. Thanks a lot for joining in. So glad to see you all. I'm going to share my screen and go to the presentation here. So we have maybe waiting for the students to come in. I think they typically arrive kind of just on the spot. So we have Chiki, who is from Mecca Bay. So she's calling in from Hong Kong. Do you want to have like a quick introduction before the student starts? Because right at 11 we will start. Would you like to introduce yourself briefly?
Good morning, everyone. My name is Keith.
So Keith is a Hong Konger, but he worked as a naval engineer in Australia for many years. Maybe just a few words. Now retired and volunteering regularly with Mecca Bay. So we've been having a lot of pleasure working with Keith.
So maybe I'll go next. Hi, everyone. My name is Gray. I'm director of the Swire Institute of Marine Science in Hong Kong U. And I'm interested in coastal ecology and marine biology, basically. And thanks, Cesar, for inviting me to join this. It sounds fun.
Yeah, thanks a lot for joining. And you're calling in from Hong Kong?
Yeah, that's right. Yeah. So I'm just in Pok Fulam.
Then Calvin is the student. Daryl, we work with Daryl from the Canadian International School.
Hi, Cesar. Hi, everyone. I'm a high school science teacher and the department head for science at the school. And we've worked with Maker Bay on several occasions trying to do things. And one year, a somewhat related project to this about innovations in cleaning up oceans and things like this too.
And we have the other 3 students. We also have Daniel Kinzer, who's I think calling from Hawaii. Aloha, Daniel. If you hear us.
Yeah, aloha Cesar, aloha everybody. Thanks. I'm calling in from Honolulu and I'm a longtime educator and have worked with Maker Bay in the past on some really fun projects in Hong Kong and China. And yeah, love biomimicry and all things related to the ocean. So looking forward to hearing what the students came up with for today. Thanks, Cesar, for having me.
Oh, thanks for joining. Okay. All right. I need to make sure that the presentation is recording because some people are not going to join right away, but they will watch the. Okay, it is recording. Okay, good. So we'll start exactly at 11. So there's two more minutes. So just a few words to in the direction of Gray. So the ORA, the Ocean Research Alliance. So I sent a message to Kenneth, Professor Kenneth Long, but he told me that recently he actually handed over the leadership of ORA to Professor Zhong. And I thought, okay, maybe, I think it was too short to invite him yesterday for today. So I'll send him the recording. But the idea is that after this session, I will open up, I will send the documentation to the group and try to invite more people of the ORA in for further discussion and definitely for the final presentation.
Okay, that sounds great. As you know, I've been chatting with Dave Baker about this a little bit as well.
Yes.
So this has been something which we've had kicking around in the back of our minds. And so this is very, very timely, I think, and a very good opportunity. So hopefully, maybe we should catch up a little bit later on as well after this, with Dave. And I just wanted to mention quickly about the presentation. I'm going to sort of dip in and out. So I'm probably going to take the video off so it doesn't distract the students.
Okay, no problem.
But anyway, maybe we can get together with Dave later on, maybe next week or something, yeah?
That'd be great. Yeah, that'd be wonderful.
Excellent.
Yeah. Switch those on. bit more visible. Okay, the students are joining in right on the clock. Okay, almost to go. Okay, I'm just gonna wait that another 30 seconds and then we get started. Okay. Hey, Jason. Okay, so let's get started. Or maybe I'm gonna put my headphones because there's some noise in the background. Maybe the sound would be a bit better. Somebody's drilling, of course. Perfect timing. Do you hear me well? Everybody, can you hear me?
Yeah, I can hear you.
Yeah.
Okay, great. Okay, so let's get started. So welcome to the Floating Marine Laboratory. This is session number 8. We have this is the crit about the concept and some of the early designs. We're very lucky to be joined with a number of Hong Kong and also international guests. We have Chiki Bhavnani calling from Hong Kong. We have Daniel Kinzer calling in from Honolulu in Hawaii. Gray Williams, Professor Gray Williams from the Swims Institute. We also have Jason Hilgefort, who is also a faculty in the architecture and landscape. Dara Sharp, who is the coordinator of science for the Canadian International School. Keith, who is a retired naval architect, naval engineer, worked in Australia for many, many years. And we have also Gordon So, who is not a student. And we also have Wouter, who is not a student, who is going to be helping evaluating. I'm really sorry for the background noise. It just started drilling just now. Okay, so I'm going to try to keep my introduction to be as brief as possible to maximize the time for the students and to maximize the question that you can ask and the feedback you can give to them. So just first, some really generalities. So when we look for life outside of Earth, we always look at the presence of water because water, in our current knowledge, is where all life on the Earth at least was originated. And 90% of the heat that comes from the sun is captured and in the sea, regulates the climate. 90% of the world trade is transported by shipping. 75% of our oxygen that we breathe today has been generated from the ocean historically, so not right now, but historically through algae processes. 71% of the surface of the planet is covered with water, and 26% of our carbon is absorbed by the sea. So we can't underestimate or can't overstate the importance of the sea. But the sea is also really, really suffering, whether it's from agricultural runoff, industrial runoff. We have a lot about plastic pollution because it's very visual, but we have also oil and radioactivity, which is less visible. And we have also, more and more drugs flowing into the sea, and a lot of abandoned fishing gear that keeps fishing even past the time where humans collect what they sow. So right now, approximately almost half of the world population directly depends on the sea, whether it's for the protein that comes from the water, or because they live nearby the sea, and so the economic activity depends from the sea directly. So again, like we basically come from the sea, and now we greatly depend on the sea every day. And now that the sea level are rising and large population live in cities next to the water, then the effect of global warming and sea level rising are going to have a huge effect, and we can anticipate hundreds of millions of refugees coming from those urban areas are going to have to shift their position or change the relationship that they have with the sea. So I just want to refocus as well that the studio here is not specifically about designing floating cities. There's a lot of discussion about designing those floating cities. And in my point of view, a lot of them are kind of going a little bit ahead of themselves because there's not a solid understanding of the long-term impacts of developing such infrastructure in the sea. We like to think that those floating cities are going to be eco-cities, but the problem is that a lot of those proposals don't have a very detailed idea of how they're going to deal with sewage or waste management, for example, or produce their own electricity. So there's a lot of architectural speculation about how we're going to do that, but there's a weak understanding of how we're going to do that in a sustainable way. So what the studio is looking at is to establish the scientific foundation to understand how we're going to be dealing with those different components. It also reflects from a growing interest within the university as well. So there's a new group that's called the Ocean Science, Ocean Research Alliance that's been formed, which is an interdisciplinary group at HKU, which is going to be a group that combine ocean scientists, which maybe come from like the more, what we expect to have like ocean science, like marine biologists, obviously, and like oceanographers, but we also have, say, mechanical engineers, electric engineer, computer scientists. So the idea is that those new, this interdisciplinary approach of having a group that has people from multiple backgrounds will enable more innovative research to be produced. And the idea as well is that eventually we might be applying for national funding. So China is very, very interested in developing ocean science projects. And so maybe the central government eventually would be supporting some of the things that the ORA is doing. And so the idea is that the students in this group in the studio, so 15 of the master students from the HKU, would be conversing and making a proposal that be evaluated by the ORA. And maybe eventually this proposal can actually be built to the ocean science to build the foundation for building the future like ocean cities or doing ocean science in general. In order to create the maximum value for this floating laboratory, the idea this is not purely ocean science, it's ocean science that is really applied. And so the idea is that, okay, we use this platform to evaluate how we can create value for people. And so we're looking at fishermen, seafood, NGO and eco-activists, coastal communities. We're looking at all these stakeholders and how they see that this platform could create value for them. And so the project is running into different stages. What you are here today is basically R1. We're looking at the background research that the students have done. So they have done background research on the previous topics that I mentioned. And then each of them individually are going to present individual concepts and designs. In the next phase, we're going to be looking at what are the best or most valuable ideas, and we get the students to work together. So we are working not in a divergent way, we're working in a convergent way. I mean, the divergent way was until now, but for the step forward, we're going to be trying to see how can we get the best idea of each of the students and combine this into something we can actually make. Because obviously we won't have the budget to actually build like a 15 platform, but the idea is that we want to learn from each of the research of each of the students. So the structure of the presentation is going to be as follows. We have so 6 teams, I think, or 7 teams. They're going to first present the background research during 5 minutes. So then just in an uninterrupted 5 minutes, all of them, like one group by one group. And then individually, each of the students will have 3 minutes to present their individual concepts. And then they will have 2 minutes to get some feedback. So you can ask them a question. So maybe ask them a question or make a comment. But I've prepared as well a form. So I'm going to ask you now to all maybe take your phone. So like this, you can have on your computer, you can see the presentation. But if you can take if you have an iPhone, you just take your phone. And you want to scan the QR code. So if you scan this QR code, then you click on it, and it will take you to a Google form that's going to look just like that. Yep. And so this is also true for the students. So we're going to take 1 minute now. I'd like all of you to scan the QR code that you see on the screen, students included, and you're going to be scanning this. And so when you get there, you will see that there's a form that has been prepared for you. And there's going to be the name of each of the students. And so I'll ask you to click for each of them to evaluate the background research, functionality, what you think about the technology and the innovation. Aesthetic and culture is basically the beauty or how appealing you think it looks, the environmental impact and presentation. Functionality, I should mention a bit more. So for example, let's say I see Tracy who just joined. So for example, Tracy, if you are an environmentalist and eco-activist, I would like you to evaluate this platform really from your own perspective. Think, can I use this platform to do my work? Can I use this platform to do the activism and to do the educational program that I want to do? If you are Daryl or if you are Daniel in Hawaii, then you want to look at this and think, okay, well, can I take my students on this? Is this going to be practical for me to deliver my classes? So I want everybody to think, from your perspective, and to evaluate, and be tough. And you will see that for each of the students, there's a comment section. So if you see a project that you think is cool, but you know there's something that is similar that you want the student to know about, or if you want to criticize, or if you want to suggest readings or scientific papers that you want them to check out, you can put that in the comments as well. I'm going to copy paste the link of this presentation, of the form, just so to make sure that everybody also has it if they join later. So I'm just going to copy paste it, and I will put it in the chat right here. Okay, so I'm going to put it in the chat for everybody. So this is the form to evaluate students' presentations. Okay, do you have any question or how this is going to work? Or did you get enough time?
Yeah, I have a question.
Yes.
Hello, Cesar. Can you hear me?
Yes. Yes, I'm waiting for your question.
Okay. I saw in the email you gave us, we'll have 3 minutes to present our background research, but it seems that in your slides just now, you said 5 minutes. I want to clarify the time limit.
Yes, I apologize. It is 3 minutes. Sorry about this. Sorry, my bad. It should be 3 minutes. Sorry about that. Yeah.
Okay.
Yeah. Great. Does anybody have any question, or did you all manage to open the evaluation form? Are we good to go? Good to go? All right. Excellent. All right. So let's start. Oops. So the first team that we have, if you open the form, sorry, no, that's not the break. So I'm going to give up my screen so that the person can go. The first person to go is okay. So you need to okay. The first person to go is going to be Nathan. Nathan, are you ready to present?
Yeah. Just a second. Trying to share.
Okay. Perfect. So Nathan, in your team, there is also somebody else. So first you want to present the background research for 3 minutes, and then you present your design.
Okay.
Yep. Let's go.
Just a second. Oh, this is the full screen. This is the full screen.
Yes.
Okay, never mind. I'll put this. Okay, so working in ocean science, our background research is based on the Land Out Tomorrow Vision project proposed by the government. So it's basically a new reclamation project, for those who don't know, about on these few islands over here. And the government claims that the water over here has low ecological importance, and so they made this proposal rather than to redevelop older industrial land or to like develop the countryside. So, however, the conservation groups argued that such a claim underestimated the ecological importance of the area, which includes concerns over disruptions of wildlife, air quality, and called for alternative development options. So just an overview of the project. It costs a lot of money, which is like half of Hong Kong's treasury, and researchers have concluded that it might create and add dead zones in the water. So what are dead zones? Dead zones are reclamation could further weaken the ability to dissipate wastewater and ultimately oxygen depletion. This implies a worsened water quality, smelly conditions, dead fish, a high proportion of red tides, and the dead zone phenomenon usually occurs during summer, where winds are weaker and are unable to transport surface oxygen to the sea bottom. So there are two instances. One is algal bloom, where seaweeds grow rapidly on the water surface, so an image like this, and hypoxia, where the algae dies and sinks to the seabed. And when the bacteria eats up the algae, it uses up oxygen, so it creates oxygen depletion deep in the water. So like fishes will die. So this is basically a simple diagram that depicts the dead zone implications, where there's no wind and sunlight couldn't enter the bottom of the water. Yeah, and we also did some research with interview, and Silver will continue to speak on that. Silver, do you want to speak up?
Okay, so in this topic, we have an interview with Dr. David Baker. He's the association professor from Hong Kong U, who is main research on the marine science. So his teaching areas mostly about the environmental science and pollution, and also about the coral reef ecology. So we asked several questions about the dead zone and the landfill at the very first station. Okay, so next slide.
I'm sorry, the time is up, and I have to make sure that everybody gets a fair share. So I'm going to have to ask you to finish in the next 30 seconds. I give you another 30 seconds, but yeah, please go ahead. You're going to have to go to your, because there's so many of you. I'm sorry if
we could go to our design. It's fine.
Yeah, thank you.
Okay.
Thank you.
So the first design is on the creating an oyster farm. So here I imagine that there's no measures to prevent water dissipating systems to decrease the amount of nutrients. So because one big factor in the algae production is the nutrients through the wastewater. So to be specific, nitrogen and phosphorus. And I created this kind of floating laboratory to kind of capture the developed algae, and through a net to trap algae, for example, and then we have an inland collection, which could be connected to places next to the dead zone. And we have these spinning motors that attempts to collect the floating algae. Circulation rings where people could walk around, and then motors in the bottom that could change direction and to match with the current flow. And finally, an oyster farm for people to kind of to make use of the algae to grow oysters, basically. So one reference that I used was through the New York waterfront, where they collected all these oyster shells and exposed them to sunlight for a year to get rid of all the bacteria, and then they used these shells to put it inside the water to regrow the oysters again. So I made kind of these prototype modules in a approximately 9 meter by 8 meter polygons, where we have a 1.2 meter circulation ring that allows people to walk around. So these polygons are designed so that they could connect to each other, and like for future development, it could go on and continue to build up. So these, for example, we have one like circulation ring. These are all basically the same dimensions, but with kind of different functions in them. And here you also see So for example, in this section, we have the net that kind of traps it, attempts to trap the algae, and then a motor that brings the algae up. And it's the oyster farm over here, and this could be a laboratory or a market that opens up to the nearby community. And we see that we can use a floating concrete as a module, and where we could build pipes below that transports all these chemicals or water around the whole structure. Yeah.
So the design tool is about the algae farming laboratory. Okay, this line. Okay, so the concept of this algae
sorry, just
farming.
hold on. Just a second. So are you finished, Nathan? So
Yeah,
you
yeah,
can
yeah.
get, okay.
Oh, okay,
So,
okay.
so you can get 2 minutes of question from the audience, and then Silver,
okay.
you can
Oh.
you can do.
Okay.
Yeah. Sorry to cut you. Okay. So what are the questions from the audience? Maybe the comments.
I have a question.
Yes. Please go ahead.
Yes, with the big net that you show on your design, can the net actually trap also animals and be a problem for animals?
Yeah, I think that would be a problem, and I haven't really considered this, but I've realized that there are some devices that produce sound waves that kind of like that doesn't allow sea creatures to go nearby. I think that could be one of the measures that the device could take in order like to prevent like the trapping of.
Okay, thank you.
Yeah, thanks.
This is Gordon.
Yeah.
Yeah, I'm from WWF Hong Kong. So about your design, it's quite interesting, and I would like to give some comments for you to look into it in the future. So actually, Hong Kong also have oyster farm, and another NGO in Hong Kong, TNC, the Nature Conservancy, actually are doing projects in their oyster farm. So kind of like semi-fishery and semi-scientific. So you can have a look at it. And on the other hand, well, the oceanography of Hong Kong is actually quite interesting. The western and eastern water actually have very different salinity and also habitat. So for the western water, actually, we have a more fresh water based salinity, while in the east is more saline, and therefore oyster farms are usually located in the west side. So you can have a look at it and see if you can improve your design.
Okay, thanks.
That's a great. This is a great reference. If you want, you can add this reference in your form. And so this, if you have some link you can share with them, that'd be super helpful for them. That's one of the benefits. Yeah. Okay, great. So now, Silver, are you ready to share?
Okay.
Yeah.
So let's start the design tool. The design tool is about the algae farming laboratory. So one of the reasons of the death zone is algae bloom. There's a low oxygen in the sea and COVID-19 in the sea. So that's why I would like to make use of the death zone and the algae materials. So we build a floating algae farming laboratory and collect the algae surrounding areas at the same time. And the floating solar panel system can support the whole system. Okay, this. Okay, the use of the algae can be used for fertilizer and industrial and commercial use of the algae. Even energy source can be used, and last can be used for pollution control of the wastewater. So not only the algae farming system, it can be a potential cooperation program just like floating greenhouse and floating renewable energy. Okay, so this. So my design is similar to Nathan. Is also similar to the prototype, but we can see there's a big algae farming in the center of the site. So there's a track in the middle. So at first there's an algae collection machine to try to collect the algae surround the zones, and then the algae collection machine can be sent to the algae farming laboratory to distribute the elements of the algae so we can see the laboratory house is extruded. So after distribution of the algae laboratory, so this will send to the in the middle. There's a kind of the track to keep moving, just like the photos of the paddle wheels. So keep moving the algae and goes up the algae. And the whole system can be supported by the middle. There's a solar panels, floating solar panel system in the middle. So the paddle wheel can be keep moving by renewable energy. So and so for the running of the algae farming, the CO2 bubble is also part of elements in this design. Okay, so this. So this is there's an algae collector prototype. So at the picture we can see how the algae can be collected by the machines. So but actually we can see the machine is only can collect surface algae. So I have designed the new prototype. This kind of can be moving different depth of the sea. So can be collected even the depth algae close to seabed, because even depth algae they will still consume the oxygen. So that's why they can try to move from different depth to collect all the algae to try to improve the death zone condition. Okay, this. So this is the section. So we can see the difference level between the algae farming, the algae track and solar panels, and the algae cluster machine can be moving by the depth from the section. So yes.
Did you finish? Or do you want to? You good? Okay, maybe 2 minutes for questions or for remarks or suggestion. I see that Daniel has suggested to look at a project called Green Wave.
Yeah, Silver, Nathan, I love the project, and I've been really interested in exploring aquaculture and ocean agriculture, and love to think of the opportunity not just for growing oysters and collecting algae, but really doing ecosystem restoration. So how do we bring, instead of worrying about not killing fish and marine life, why don't we actually cultivate habitat for them through our construction? And I think you guys are onto something. These hexagonal, the hexagon structure, and very interesting, could really build an ecosystem out of that. So just invite you guys to think about how you could extend that design into really growing out a new habitat, new ecosystem for all the species who would like to call Hong Kong's waters their home, but maybe can't right now, but could with a little bit of help from us. Nice work.
Thanks.
Okay, thanks.
We have more questions or from the attendees. May I ask you, what is the material that you want to build the structure out of?
The floating concrete.
Floating concrete as well. I see.
Yeah.
And you want to make a pass rail, like a bridge, so people go in and out all the time, or you expect that people will be based there? So is there like a shed, like a place where you put the tools, or all the tools are on the land?
So they can keep move the algae to the land to maybe to cooperate with different programs, like industrial in the island maybe. Yes.
I see. Cool. All right. Okay. Thank you very much.
Thanks. Thank you.
Thank you. So move to the next team. So we have fishermen, I think, with Sun, Zheng Yu, Chan Chong-kit, and Zhang Huze. So who is going to present on the behalf of the team for the research?
Yeah. I'll share my screen.
Yeah. Great. So you want to click on present, so it's full screen. We can. Okay. Ah, much better. Okay.
All right.
Yeah.
Is it full screen now?
Not really. It was better just before.
Okay. Thank you. We are a group from seafood and fishermen, and our main focus is the sustainable aquaculture, and we research it for some details. After the background research, we know that it is very urgent to develop sustainable aquaculture farming. Like there is a rapid increasing demand for protein and seafood. We need to raise more sea species to meet the need. Like when people doing the nearshore fish farming, here, the fish waste and extra feed will accumulate at the bay because of the sea flow direction. It's hard to make use of it, and it will pollute the ecosystem there. Also, the sea lice and other bacteria will affect the seafood raising activity if the system only contains one species and spread in a high speed rate in the system.
And we invite 3 experienced people to our interview program. One is the founder of a Hong Kong aquaponic company, which named the Evergreen Republic, and a professor of a science department at HKU. And another one is a Singapore fish farmer who designed a closed loop zero waste farming system which can recycle the waste from one fish as a food for another one. And as a result, we got some advanced aquacultural technology and opinions from them, like deep ocean aquaculture, because the deep sea water will be pure and more stable temperature for fish growth. And in aquaponic system, fish wastes are the natural nutrients for plants, and the plant's roots can be a nutrient filter for the fish from the water. Yes, finish.
So through the readings and interview, we understand the current problems of which aquaculture is facing, and we also got information from the researchers and companies who have innovation upon this topic. Based on the research, we would like to come up with a possible platform for the fish farmers to practice in a sustainable way. So after the interview, we conclude some major concerns in our later design. How do we generate power in an affordable way without pollution? Or we also need to have appropriate location for the species we raise, like algae, oyster, and mussels, and fishes which live together and have good impact to the ocean. So, and also the structure and operation also need to be concerned, which is to consider about how it works when the typhoons comes. So that's all of our research presentation.
Okay. Thanks very much. So we'd love to see your design. Son or whoever is ready in your team to go first. Who's going to go first?
Yeah, I'm gonna go first.
All right, thanks.
Okay, I'm Zhenyu, and I'm going to introduce my floating farm design. My inspiration comes from the green wave regenerative ocean farming practice. They develop a kind of farming system that raises seaweed and mussels and oyster, which can absorb the carbon dioxide and purify the water. My concept is to add fish into this system and make the system a closed loop and divided every system into a small unit, but it was a multi-level unit. The seaweed and oyster use the nitrogen substance in the fish waste to grow, and the oyster shell and seaweed can be made into powder and used as fish feed to raise the fish. Also, the unit can be expanded to large scale, and people can walk on the surface or to take samples. And when typhoon comes, they can break into small cells and drag away by the ship. Here are the sections and plans of the single unit. It's a 7 meter wide and 6 meter length rectangle floating platform with a 4 meter wide and 3 meter length hole in the middle. Various seafood species are raised in the cages of it. Fish is raised in a double layer net The inner one is with bigger holes so that the small fish could survive when they harvest. And with mussels, they are at a height of 3 to 4.5 meters underneath water, and oyster basket at a height of 7 meters. They can purify the water in the area and use the fish waste to grow. Surrounding the platform, it was the ropes where seaweed grows. They absorb the nitrogen in the fish waste. When farmers have to harvest, they just use the pulleys to pull the seams up and to have an easier way to collect this seafood. Here is the illustration of a single unit. When they need to move to another place, they can get rid of the anchor and tie to a ship like here and move to a more safer place. When they don't need to move, they could be tied together to form a bigger platform with a 3-meter wide route for people to walk on. They can observe the situation inside the net and cages and take samples of the water inside it to make further research. The full picture of the connected will be the first one like this. Okay, that's the end of my presentation. Thank you.
Thank you. Okay, great. So questions or comments? I think the pulley idea is really, really good. So the pulley are on the edges or they are in the middle? Where do you hold the pulley? Do you have multiple of them or just one in the middle?
The pulleys are here
In the middle.
and in the middle is for the drag of the fish net because it's more big and heavier. So people can rotate it like here.
This idea of double net, is it something that exists right now in fisheries, or this is your concept to have different gauge nets?
I think it already exists.
Well, I think, hello, this is Gordon. I think this system is very likely to work, as I saw similar design in local fish farm. I mean, not that high tech, of course, but that combination of fish stock. For example, oyster. I saw people are cultivating oysters with lobsters. And usually, well, seaweed will be difficult to control, as you know, all the plants will go into your nets randomly by ocean currents. But the lobsters are actually a grazers for seaweed and also for the waste generated by other organisms. So it is a very good cleaner for your oysters, actually. So you can generate some high economic value seafood using this kind of system. They're very good design.
Okay, thank you.
Hi, it's Tracy from Plastic Free Seas here. Can I just ask what materials will the platforms be made from, and have you any thoughts on how this would actually react in a typhoon situation?
The platform was made of wood and it was anchored to an inflatable raft. But when facing the typhoon, we choose to move to a more safer place. In advance.
Okay, so you don't know, I mean, if it's, I guess the safer place could vary, different typhoons, or there could be no safer place.
Yeah, I do believe that typhoon is a very huge problem for most of the aquaculture farms in Hong Kong, especially, and it's an obstacle that really difficult to handle.
You mentioned that, Tracy, because after a typhoon, you see a lot of debris from the fish farm.
Yes, absolutely. I mean, obviously different materials. A lot of the fish farms seem to use a lot of polystyrene as their sort of flotations, or loosely tied on random things. And yes, we do see a lot of that ending up on the beaches after typhoons.
Do you know if there are like a more ecological material for flotation alternatives for styrene?
I don't. I know there was some work done on trying to replace polystyrene, the foam boxes, the fishing boxes. I'm not sure what the end result was with that. It really depends on how it's being used and what the best material is for different applications. But yeah, trying to avoid polystyrene at the most is preferable.
Thanks a lot.
I can add on a little bit. So traditionally, not really traditionally, but like 20 years ago, aquaculture farm mostly made by Blue Giant bottles. But right now, it seems like there's a transition to polystyrene boxes. And the bad thing about the polystyrene floating material is that they easily crush into small pieces, which is much more difficult to clean and much less difficult to much easy break with typhoon and waves. So I saw that people comes up with a solution is that they use some cloth or some plastic wrap to wrap the whole polystyrene thing so that it prevents it from breaking into smaller pieces. But sometimes the wrap also goes away with the typhoon.
Okay, we need to move. Thank you very much. Maybe we'll talk more about this in another. So who's going to go after? I think we have Chang.
Yeah, I can share my screen.
Thank you.
So, check, and more I would like to share my concept, also a floating farm. So my concept is based on the same principle that a multi-level farming which contain fish, algae, and mussels in the system. They feed each other, and the waste they produce is less. At the same time, algae and mussels can clean up the water. So when considering the typhoon, I would like to moving the farm before typhoons comes rather than building a robust structure to confront the big waves. So and I suppose that it needs to be flexible so farmers can control it easier during operation. So here is the prototype. Hexagon fish cages are connected by ropes. Algae can grow on the ropes. At the bottom, we hang mussels under the seaweeds. So and then we add sea, and I added sail and rudder in different cages. And here's the proposal for bigger farm, forming a bigger farm. In normal situation, the fish cages are anchored on the seabed, which is in shallow water, like 15 to 20 meters depth. When typhoon is coming, we pull back the ropes with mussels and algae. They can be wrapped around the stakes on the farm, so the cages can be packed up in units. The farmers can unfold the sail, and the farm can move to a safe bay. The sail can also be used when harvesting. Farmer can use the wind power to help disperse the fish cages, and the ropes would go up to the water surface for harvesting. So these are the pictures showing the operation of like sailing and harvesting. Material for the cage is plastic tube. On the top, it can float on water by inflation, covering with wooden boards so farmers can walk on it. In the bottom part of a cage, the tube would be filled with water to balance the buoyancy. In one module, the sail is inserted to the center pole. Another module is inserted by rudder. We will need also a wheel to control the rotation of rudder at the top. So that's all of my presentation. Thank you.
Thank you. So questions?
Well, very innovative. That kind of freed modes for the farm to move, selling, harvesting, and also farming. Just one comment on the use of words. I saw you use the word sarcasm. So according to the local biology of Hong Kong, sarcasm only appears in Hong Kong between February to April. So I guess it's better for you to use the word some sort of seagrass or algae.
Okay.
But otherwise, the design is very innovative, in my opinion.
Thank you.
So would you just use the sail to kind of move it away from the typhoon, or would it be also towed?
Sorry, pardon?
Would you use just the sail to move it away from the typhoon, or would it be also towed by a boat like your structures?
I wish the sail can have enough power to move it. It needs tasks, it needs science to move it. It's
Okay,
still an imagination.
Is this to use in the open sea, or you imagine to use this like more in the busy waters of Hong Kong? Or you want to put this like far on the sea?
I suppose it would be anchored in a shallow water area, like 15 meters. I mean, around Hong Kong area.
Oh, Hong Kong. Okay. Okay, thanks very much. Okay. Okay, so the next person in your team is Zhang Huzhe.
Can you see my screen?
Yes, we can.
Okay, so let me start. So in my individual design, I'm focused on the open ocean aquaculture. And based on the above the research information, I want to have a like aquaponic system on the floating farm. And you can see there have a many solar panel, and to provide energy to aquaponic system. And in order to provide as less pollution as possible to ocean, I refers the zero waste farming system. So you can see the fish, seaweed, and many different kind of shellfish. They can friendly live in the different layer of the same farm. And another big problem for open ocean aquaculture is typhoon. So here has a wind speed sensor, and the panel structure will close when the typhoon is coming. So the shape of the floating farm will become a tubular shape. I think this small top and the big bottom shape will raise survive chance in the typhoon. So this is a final model for closed zero waste farm system. Above the water structure is channel panel and the wind speed sensor. And underground structure, I use different scale mesh for the fish net in different layer to protect the fish and the shellfish. And at the bottom, there have a inflatable panel. It's full size inflatable panel, and here has a pump inlet. When we pump air to the bottom panel, the inflatable panel will carry all the fish and goes up to sea level that can easily to catch the fish something. And here has discontinued form, so the whole structure can easily to folder when the structure goes up. This final one, the typhoon is coming, every panel is closed, and air goes up, structure goes up. Finally, people can easily catch a fish just as like on the ground. Yes, thank you.
Very good timing, impressive. I just have an opening question. So your structure, is it completely closed or is it actually open? Because in one drawing you have this red line that shows like it looks like it's closed, and this one looks like it's very open.
This one?
Yes.
Yeah.
Is the structure really closed or is it very, very open and the water can flow through?
Not totally close because it also have some gaps, but on the top of above the water structure is like just a flat, so it's I think it's very safety in the typhoon.
Other questions or comments?
I think it's a creative design to use air to raise the bottom for easier harvesting. But one point that I would like to point out is that a giant structure under the water may attract a lot of algae or bivalves, for example, mussels or other shellfish to grow on your giant water bottom structure, especially all the fish waste, for example, their poo-poo, will drop onto your giant's bottom and things will grow on your bottom. It is going to be inflated and it may easily broke by those shellfish. So this may be a point that you have to think about it.
Yes. Yes, I think this is a very good question, and I didn't to consider about that. But I think it can easily to solve on the material. Maybe a steel panel on the air panel, maybe.
Yeah, I hope so. But yeah, I'm not a material expert.
Yeah, but
Thank you very
it's
much.
really useful. Thank you.
Thanks a lot. So this was the first group for fishing and seafood. The next group, I think we have James. James, are you there?
Yeah. Hello, can you hear me?
Yes, we can. Okay. So your team is just you, right? This is just you in this team? Okay, so you're going to be presenting first 5 minutes your background research and then 3 minutes for your personal design.
Okay.
The floor is yours.
Okay, thank you. So hello everyone, this is James, working on an urban waterfront project. In the past month or so, 4 stages of work were done to start my Hong Kong City waterfront research. Written in the diagram, first quantitative analysis was done, then followed by literature review and qualitative analysis before the prototype design. Starting with the quantitative analysis, I looked into an online survey that canvassed concerns and demands of participants regarding Hong Kong City waterfronts. In general, people would like to have less spatial and program restrictions, more variation of landscape experiences. For the second step, literature review was done to review other prominent issues regarding waterfront development. Additional dimensions like waterfront resilience against natural disasters, water-friendly landscape designs came up. These dimensions led towards the next stage of qualitative analysis, in-depth interviews concerning dimensions presented earlier on. Results are synthesized to give design directions under each dimension. Spatially speaking, people demand less protective designs, especially with railing. And to raise waterfront resilience, planting is preferred over hardscape structures since they're visually more pleasing and have ecological benefits. Lastly, for programs, more diverse cultural activities, water-friendly designs are things that people look for. These directions brought me to propose spatial designs at the land and water interface, looking at the local natural water edges and overseas water-friendly hardscape coastal treatments. I ambition to blend these imagery together in the design proposal, considering also the context of Hong Kong coastline, which receives daily strong wave actions and typhoon strikes in the summer. Existing landscape technologies are referenced as the first step. Apart from the overseas coastal step terraces bringing people to the waters, the riprap walls shown in the images on the left are standard typology created by the Hong Kong Civil Engineering Development Department, used along the city waterfront. The inclined boulders mitigate wave power before the seawater smashes at the seawall. My design proposal develops upon the riprap technology, pushing it towards the sea and closing the first soil medium bed. This soil planter is envisioned to submerge in seawater during high tide. Mangrove plant species will grow on this soil, while tidal movement facilitates the soil and plants to breathe daily. Adjacent to the first, lower soil medium, is a second it's this second riprap wall, higher in level, that encloses the second soil body, which serves as a rarely submerged zone for facilitating recreational activities and ornamental planting. Since in the Hong Kong tidal pattern, the high tide ranges for a meter or so, the recreational zone is anticipated to be partly submerged only on the few days of the month with the highest tide level. The overview isometric drawing envisions in 3D the spatial layout of the design proposal. The zoom-in perspective drawings explore more detailed design elements like a durable walkway, probably by concrete, along the riprap walls to provide a constantly dry and walkable coastal environment that facilitate water-friendly activities. Regarding programs, the higher level soil will be similar to the typical promenade recreational space setting. For the lower soil, as reference images suggest, the semi-natural coastal environment in Hong Kong have been quite attractive to the general public. People would informally conduct various activities that are feasible according to the water level, wetness and softness of mud at each specific tide level. So the core objective here is to set a feasible spatial framework, promoting water edge resilience and flexible spatial design while leaving rooms for people to decide what programs and activities they like to do. Moving on to the details, further design of the riprap walls are required as they are meant to retain soil, and the current large boulders have gaps between that waves would bring away the soil medium. It is suggested to attach 2 layers of geotextile sheets, since they're only permeable to water, onto a concrete slab with lots of holes across for water permeability in the middle of the riprap wall structure for holding the soil in place, at the same time allowing seawater's penetration into and out of the soil medium. Thus, the soil medium can receive daily water exchange, breathe, and be a functioning planting medium. The last few slides attempts to implement the strategy on actual sites. The Chung Fan Old Promenade was taken as an example. Considering the modified coastline after future transport infrastructure construction, the new waterfront design is created to form the above-mentioned layers of mangrove belts and recreational zones. This is the end of the presentation. Thank you.
Great. Questions or comments?
It's me again. I hope I'm not dominating the comment section.
No,
but
no, please.
Yeah,
Great. Thank you.
I can give some input. I think it's a very good idea to incorporate mangrove benefits to the society into the barrier design. So, for example, as a wind shelter and also as a rich biodiversity habitat. But one concept that I would like to mention, it's a biological term called a habitat fragmentation. So in the mangrove system, there will be a lot of organisms live inside, for example, crabs and clams, and even horseshoe crab. So if you break down, because now you have 2 mudflats in your system and you have a walkway in between. So it indicates that all the terrestrial organisms cannot transfer between two mudflats. So for example, the inland organisms can never go to the seashore through walking through the mud, because in between you have a walkway. So in order to improve the biodiversity of your mangrove system, you have to create some channels, or we so-called eco corridor, so that you allow organisms to transfer between mudflats so that they can reach different areas. I think this will be a way to improve your design.
Thank you.
So you mean that instead of having like a solid path, it would be more like stepping stones? So at least there are some gaps? Is that what you're saying, or it's got to be no road at all?
Yeah, that could be a way to do it. Or you can, for example, add some pipes under your walkway so that things can walk through. Oh, but plants cannot walk through the pipes, but you know, that kind of idea.
Thank you.
Okay, thank you very much. Great. So for the next person we have is a different group. So James was a very small group, a single person group, but they worked on the same topic of urban waterfronts. And so the next team, we have Ceci and Oswin. So if you are ready to go. Yep.
Yeah. Let me share my screen. You guys can see my screen, right?
Yes, we can.
Okay, I'll start. So Ceci, go.
Yeah, so good afternoon, everyone. We are the Group B, and my name is Ceci, and this is my partner here, Oswin. So we began the research with doing survey with the public to understand the public's view towards the urban waterfront of Hong Kong. So under the circumstance of the virus, we have interviewed 7 public aged between 18 and 70. And in the first part, we asked about the general perception towards the waterfront. The key takeaway is that they think marine is important, yet they feel distance in terms of the relationship with the marine. And then we asked about their personal experience. And then the key takeaway is that the strolling is the most common activity among the interviewees. We also asked about the suggestions and concern, which gave us some direction for the initial design. We will further talk about it in the next few slides. Last but not least, we utilized the concept from the book Image of the City by Kevin Lynch and provided the interviewees a blank piece of A4 paper to map out the experience.
Yep, so from the takeaways from the survey, food is actually a driver that drives people to the sea for some reason. A lot of the interviews said they would be grateful if there could be more food-related programs along this urban waterfront. And then based on the image you can see here, it's really surrounded about the kind of the visual anchors. So it's again, it's really important to construct that image along with the sea in order to kind of include the kind of this idea of marine in their lives. And thirdly, a lot of interviews said they would prefer to have this animal-friendly concept along the waterfront because the facilities are lacking at the moment. So looking into the pain points based on the background research, the first one, we kind of look into pain points of the current marine net, also the idea of living on the ocean. So first of all, it's the inert and high cost structure that limits the research possibility because it's really redundant when you build something that it's only enabling to float with high capacity, but very limited. It's not really kind of allowing users to go to kind of research into the water because it requires a lot of carrying and it's not built specifically for research. And secondly, the isolated location, because as you can see here, a classic example, it's so far from the city that requires people to walk to get to. And third, it's an unsustainable financial model, which usually uses research grant. And lastly, they build their living model based on the land design concept instead of thinking about how we actually live in the oceans. Yeah, so that's our research part. Do I continue or? Okay, so to continue, our design actually is quite greatly integrated. So perhaps we will be back and forth between CC and I. So our design is called the Ocean Collab. It's actually a self-sustainable research research lab and for imagination. So our site actually tried to locate it along the urban waterfront of the city, located along the green open space indicated here on the map. I think my laptop is lagging at the moment. Wait, can you, I'm not sure if I'm on the same page as you.
What we're seeing now is a map with the zones. With the
Wait, how about now? Can you see the next page? Because it took a long time to load the next page. So I focused on designing the overall structural system of the platform, which consists of mainly 4 components. First is starting from the bottom, is the changeable lab or service units based on the kind of what the researchers want to do with their research. And this and the one in the middle, it's the aluminum core framework. It's a 6 by 6 meters framework divided into 4 by 4 units. And on top, it's a removable tile flooring, allowing them to actually get access to the water when necessary. And on the above, it's a structural column system that basically allow a really flexible construction based on the need of the researchers. And looking further into details, this core framework, which is basically the backbones of the entire system, can be constructed easily with CNC material, CNC, and then so that the cost is super cheap. And then it consists of various mount to mount the units that the parts that I talked about. And if you flip around this particular framework, it can extend itself and multiply itself.
So in terms of the units I have developed, they are based on a lot of existing technology. For example, we have the waste to energy unit, the seafood farming unit, and the water treatment unit, etc. So, so this is the detail of the assembly when all the units and components come together. As you can see, each component that I have designed integrates with Oswin's structural system and can be easily organized based on the need at the time. And for a lab with limited budget, they can start with small with the 6 × 6 meter basic lab module, and this will provide them with 16 sets of units, each with a dimension of 1.5 × 1.5 meters. So our estimation is that one lab module at its full capacity, including structures above, would require minimum of 4 floating units. And these floating units are constructed with styrofoam with external steel reinforcement covered by a thin layer of concrete.
Sorry, Ceci, so you are presenting together, but you presenting
Yeah,
maybe we'll
so basically what she talks about, it's mostly of her work, and what I talk about is simply my work. Yeah.
Okay, so present it together, and then we'll have then 4 minutes of comments. Okay, no problem.
Okay, yeah. So yeah, as you can imagine, this scalable module can eventually turn into a platform with various research programs coexisting at the same time. For example, this expanded lab on the image, we try to situate along the waterfront to create this like flow of food cycle from farming, processing, cooking, and dining. In addition, we have also included a lab called the Social Lab to offer a range of seasonal activities that research on the life of the like living on the ocean. And maybe Oswin can talk about the next bit.
Yeah. So then I think for our design of the marine lab, it's really to try to collaborate different kind of parties together instead of actually focusing on one particular area, because I think a lot of them are really specific in their own field, but a lot of them kind of distance them from each other while they are actually all integrated, all about ocean. So that's why, as you can see here, the units that the CC has kind of designed, it's actually based upon various existing technologies already. So for example, the Ecology Unit, it's actually designed by the California College of Arts. And then the Wave to Energy Unit by the Ocean Power Technologies Incorporation. And again, the Underperforming Unit. So it all comes together and it can all coexist together as well. So in turn, and the problem with being unsustainable of the financial model, we reference a precedent in Hong Kong, the marine cultural raft, which they actually offer fishing activities on raft surface and entry fee when they arrive. So therefore, if we were to introduce that food lab idea, farming lab, food lab, and social lab idea, it actually generates income, profit from the public, and then the profit can actually turn into the funding for research lab to continue other research unit, or to maintain this current lab as well. So thank you very much. This is our presentation. Yeah.
Thank you.
Great. So now we have, because we had 2 people presenting, we had double the time for questions and comments. We have 4 minutes.
Yeah.
So yeah.
I just want to give a short comment. I'm Maxine from THS, the Harvard School. I really like the project. I just want to give a comment about the survey. Maybe in order to be more representative of the population in Hong Kong, next time you could do a survey including more people.
Yeah, thank you very much.
Maybe kind of piggybacking on that comment, do you think that this is going to be like an international tourist attraction, or do you think it's going to be mostly like a local attraction? Because for example, the floating farm, I think is mostly like local for people who go fishing. How do you imagine, what kind of audience do you expect in this kind of infrastructure?
Actually, I think what we are developing is a system, and I try to actually we try to be as generic as possible, because we actually don't want to limit it to a particular context or site, because because this is kind of a platform that allows different uses. So we hope it could be global, and yeah, and the structure actually mainly I think because it's kind of based on the idea of raft. This component here, it's used for anchoring to the sea as well. The edge module. But the edge, yeah. So it's actually a kind of we hope to be scalable to all places.
Yeah. Do you have a typhoon plan?
Yeah. So I think as mentioned, the structure of this actually is to enable anchors on the edge of the unit. So as long as it's not used, this structural mount here, it's actually will be used as the anchor to stabilize the raft. And yeah, I think that's that. Oh, yeah.
I maybe refer to your typhoon question, because we have the kind of the like removable structure on top. So if we need to overcome like bad weathers and typhoon, like these kind of like above structure can maybe
removed.
Yeah, removed.
And also again for the that's a good point. For the units, it can also be removed as well. And also this, as you can see here, this particular part, we call it the pit, surface pit, allows kind of this wiring as well as piping along the entire system. And again, it's completely detachable when the typhoon comes, so the whole thing can be disassembled easily from the top. Yeah.
If I look if you stay on this slide, the kind of organic shape, do you expect that you're going to be exploiting it from the top, so from the human side, or is it going to be something that's going to have stuff attached on the outside? Like, what do you think is the primary surface that works?
So for this particular unit, it's actually called the Ecology Unit, and it's based upon this designed by the CCA. So it's to create this habitat-like environment, both on the kind of shallow water-like condition and also the underwater habitat. So to install that, we will actually, you can install it from the human platform, which is above the water. And to observe that, you can actually open up one of the floor tiles, so a scuba diver, or you can simply dip your head in to check out the life under the water. And we also actually have an observatory unit here. So this observatory unit here, this one you have to install it from bottom up. And then the visitors or the researchers can actually kind of climb down this observatory unit to observe the ecology of this unit.
Oh, yeah. So it's dry. So it's a dry box.
Oh, it's like those kind of, you know, a shark tank.
Oh, I see. Okay.
Yeah, it's like a glass that goes.
So you get wet when you get in it?
Well, I think you can get wet or you don't have to. It depends on your interest.
Okay.
Yeah.
Okay. Thank you very much.
Thank you.
Thank you.
Yeah.
Right. So the next team is about transportation and shipping, which is a single-person team again. This is Sena Lu. Are you ready to go?
Yes, yes, of course. Okay. Can you all see the screen?
Yes.
All right. So the topic that I focus is about shipping and transportation. So at first we began with like doing research, and there are a lot of articles about the shipping transportation cause the water pollution and the marine pollution, as well as the air pollution. So here is summarized about the news. So that actually inspired for the strategy of my design is to improve the working efficiency of the cargo ports. And actually there are a lot of documentation shows that by improving the efficiency of the cargo ports, which can further improve the ecology of the waters, the surrounding water. And then we came to the interview. So the consultants that I chose is company, which is Guangdong Province Navigation Group. And this is a company that owns a lot of small firms. Their activities including like many shipping services, like oil transportation, water transportation, and also the tourist transportation on water. And here's more detailed interview. So I asked some question about designing a cargo port and how can I improve the working efficiency of the cargo ports, and also how can it affect the, like how can it further improve the quality of the surrounding water by improving working efficiency. Here are some bullet points that I summarized based on the interview. So several points that I should focus is about the handling facilities of the cargo ports, like the ports complex and their working flow, and different transporting good types. Also the weather will affect the working flow of the ports. And then I chose a specific site, which is the Huangpugang Port Cargo. It's in Zhongshan City. So here is the location of the site. And here is some Hong Kong. And so it's in the gate of the Pearl River, and it's near to Guangzhou, Foshan, and Shunde. And it's a developing city. Here is like the plan of this existing ports from Google Map. Then I did a further research about the handling process in these ports and the design parameters of different facilities in these ports. And here are the data. Also, I did a research about general port complex. I sketched the plan of these ports, and also I highlight the different machine and facilities that required for these ports, and understand the dimension and the scale of different machine and their scale to the different ship types, and their, as well as the working flow. And then comes to the sites. Oh no, sorry. My design. Yes, here is the existing plan of this cargo port. And I make a very simple diagram of it. So there are two berths on the downstream, 3 berths on the downstream and 2 berths on the upstream. What interesting in this site is this area, this pink area is undeveloped area. So based on our previous talks, I want to develop it into like a space with educational use and more communal space that open for public to come in and experience, to actually see the operation of cargo ports. So this is the old plan, and this is my version of the new plan. So several changes happen here. First one is I reduced the length from the loading platform to the storage yard, which can reduce the time for transporting and then improving the working efficiency. And also I set the berth closer to the offshore, which can actually, the construction of it can actually hold the ground tighter and to protect it from some extreme weather condition. And also the rotation of the berth is following the offshore, the outline of the offshore, which can for the ships better to get into the berth and finish their loading and unloading process and get away from the berth to reduce the time. And also add more cargo space for the storaging, and there are more groups for them, which make like different cargoes can be more accessible, and also improve the, like reduce the time for the workers to access a very specific cargo zone, let's say. And also the working area, some working area right here, which is the inspection platform, and there is some sewage treatment station and water supply station. I put them closer to the public space for people to see how it works. And here is, I'm still working in progress. So my little thought is to kind of elevate the whole platform and make it above the water, and to bring people closer to the loading and unloading platform. And it is still like in progress, work in progress. Thank you.
你放到西门那个保安处。拜拜。
Okay, so 2 minutes of questions. So maybe I have an opening question. So the pink area that you drew, is it like a school? Is it like a school on the water, or what is who's supposed to use that elevated area?
Because it's quite a large space, so I think multiple use can be designed into it. So first is the educational use. Like I want to make like some workshop or like for students or the group of people who want to experience the operation of the cargo ports. And I also want to make a communal space for people here to relax. And so it's actually like a park or like a plaza, so it's quite open yet, but the purpose for it is to make it public. Like I want to turn something private or very professional into like a more exposed and public area for people.
So we have some educators here, Daniel and also Daryl. Like if you had a piece of land next to a big park, what would you do with it?
I'm sorry?
maybe I'm turning the question towards the audience, Daryl and Daniel, both educators. If you had access to, if you had your own port, what would you do with it?
Hi, this is Daryl. Something that fascinates me about the ports and like the large amounts of cargo that move is just the logistics of moving stuff in and out. And I wonder if it, somehow you could have interactive things for the public there or for students to visit where they could think about what the logistics are, that when the stuff comes off the boat, how it gets sorted and how it gets put back onto boats and stuff too. And there could be some even little automated, like kind of smaller robots there for people to play with and do their own tip work, like unloading and sorting and reloading of ships and things too, like a little mini port interactive activity there.
Mm.
And personally, I like watching cranes and big machinery moving around, but I don't know if it is something that would be attractive to the larger public. I think you'd have to work to make it interesting.
Yeah, that's the goal.
So it would be more industrial tourism rather than like an environmental tourism, right? That's what I get. How about you, Daniel? Oh. Maybe Daniel is not here. Okay, thank you very much.
Thank you.
Thank you. So the next group, we have Gavin, Jessica, and I think Canosa as well.
All right, yeah, I'll share my screen.
Thank you.
All right, so for our group, we are mainly focused on coastal communities. For our background research, we first looked at 5 news articles, YouTube videos, as well as 5 academic papers that mainly talked about coastal defense, coastal habitats, as well as the issue of water level rise. So I'll just skim through these. And then after that, we did our interviews where we asked residents from coastal communities, as well as more like organizations, on topics like the relationship they have with the ocean, as well as feedback for design. So we asked them questions like how their lives have been affected by changes in the ocean, as well as what type of facilities or research topics we should focus on for our platform design. So here are the transcripts of our interviews.
So we also interviewed Dana, who is the operation director of DB Greens, and she has been working on plastic pollution in Hong Kong for over 12 years. And one of the main criteria she mentioned is that although it would be great that we can automate plastic collection of the ocean, but it's equally important that we can educate people and draw a linkage between the people acts and the ocean condition. So that leads to our initial design,
which are the diagrams here. So we did 3 devices. The first one is a floating rubbish collector. The second one is adaptable sea platform, and then a wave energy platform. So based on our interview findings, we wanted to focus on, based on our interview findings, we wanted to focus on waste collection, education on ocean waste, conservation and marine biodiversity, and coastal energy harvestation.
So, sorry, can you stop? Yeah. For our design concept is a platform that utilizes public engagement using devices to function the communal facilities. For example, next page, please. For example, you have children that can play in the water splashes when waste collection is the waste sea bin. Waste collection is working properly, so engage the public to empty the sea bin before they can let the children play with water again. The second one is like water turbines on the side of the platform to generate electricity for the street lights and desk lamps on the platform. An alarm system is also implemented when the sea level is too high. We also have protected marine zone for fostering marine life growth and raising awareness of the public. So all these like devices kind of help generate different activities on the platform. And next page, please. And then here we're like trying to organize, allocate different programs within a 5 meter time 5 meters box. So the initial concept is just like filled inside a box that is floating on the surface of the sea.
For the site selection, we base on the water current direction as well as the existing activities of the communities. For example, for Tai'o, we choose the pier right next to the tourist attraction so that people can easily access that device. And for like Discovery Bay, we choose Nimshuan, which is already the place where DB Greens go for beach cleanup. And also for Hanfachin and Mawan is right next to the communities, which they can see it. And then for the Mawan is because we think it would be good to test out the area with the fastest wave in Hong Kong, the tidal in Hong Kong. Yeah. And that's for the group presentation. Maybe I will now move on to the individual design. So for my concept, I have 5 criteria. One is the device need to be easily transported so that it's like more like a boat. And then second is easy to construct so that the whole ensemble can be moved directly on to the ocean without damaging the ecology of that site. And thirdly, it should be a device that is sensitive to the ocean condition. For example, I try to link it to the trash bin, ocean trash bin. So when there are too many trash, then the whole structure will sink as well. And then the fourth is should be have a communal function like the cafe we mentioned. And then fifthly is it should provide a different angle or perspective for people to view the ocean like educational purpose. Next page, please. So this is the structure which I try to make a very flexible structure so that it can respond to the different condition of the ocean. And then I reference an umbrella structure so that it can flow up and then you can carry it with by a boat easily. And then the anchor is like a boat anchoring system. And then on the right side is the structure when it's open like an umbrella. And then the more and the sixth circular thing is the ocean trash bin that are linked to the whole structure. And then the whole thing is around 6 meter in diameter and then 3 meter height. And next page, and then this is on the left is view from the underneath, so that you can see for the diagram of the plan, the middle will be the like seaweed farming, and then the outer layer will be the mini cafe, and also it will be integrated with an education center. And then the field will be like you can look at the undersea marine life. And then the orange one are the like is also a boy and also the trash bin. So in the section you can see there is a Baycom capsule within the trash bin. So when there are too many rubbish, then the whole thing will go down. And then and then the material, it will most likely be some metal frame with like membrane or fabric cladding. Yeah, but the metal, I will think about how to do the that's all.
Thank you. We have 2 minutes for the question. My first question is that so people, how would they go? Is there like a ladder or is there like a staircase to go? A ladder, okay. So it's for young people. You expect that mostly young people go there, right?
Maybe I can add some like slope, some ram.
Mm-hmm.
Inside.
Okay. Other questions?
I think just a comment, just with the viewing as well. Depending on the areas and I guess the time of year, the actual distance that you can see in Hong Kong waters is very short. So what would the people be expecting to see when they're down if you've only got a meter or so of visibility?
Yeah, maybe for the site selection, maybe try to find a more clean area. But I think it's also related to, like, if the ocean is unclean, then you don't have that facilities. But like, it's not always functioning, the device. So people need to clean it up if they want to see something. Maybe.
So there's bad visibility, and that's part of the process. People want to have better visibility.
Yeah, and then, like, also for the trash collection, if there are too many rubbish, then they need to clean it up in order to let the whole platform float.
Right. Thank you very much. Okay. The next person in your team is, so that was Kanosa. Oh, okay, Jessica. So be careful if you are filling the form. Kanosa just spoke now, so Kanosa actually was number 3 within the presentation. So now I guess it's going to be Jessica, who was number 2.
1 second, she's having problem with her microphone. Just
Oh,
give us
okay.
a second.
No problem.
Oh, just speak through.
Okay. Unmute yourself.
So we can see a screen, but we don't hear your voice yet. A little bit.
So for my individual design.
Are you speaking through Gavin, or are you speaking through?
Yeah, she's speaking through.
Okay, so then I'll mute. I'll mute the other one. Oh, go ahead.
We're sorting it out because we're in the same room. Hold on.
Okay. I reset the clock for you.
I'm gonna. Yeah, I'll do it here. Sorry.
Okay, no worries.
Yeah, because when I was screen sharing, I don't know why my microphone is gone.
Okay, no worries.
And press the presentation. So I may know.
Looks like it's another tab just on your left, yeah?
And then present on the Yao's angle. Okay. So for my design, if you look at the plans right now, you can see my main program allocation. So basically I have 4 programs. The first one is the cafe with tables and seating on the above water level. And then there's the splash playground that is connected to the trash collection device on the above water level. And then there's a feeding deck that feeds into the marine protected zone in the water. So for the underground level, it's mainly the education center, a viewing area of the marine protected zone, as well as the bathroom. Next page. This is like a top view of my design. And in my head, I was thinking that it could be kind of connected to land. So the walkway you see is maybe like a pier or something. So it's not completely just floating in the middle of the ocean. And for its size and material, I'm thinking that it is right now 7 meters in diameter, and it is made out of plastic. So in this axonometric drawing, you can kind of see my program as well as devices. So mainly there are 3 devices in my entire platform. So the first one is a water level electricity generator, which you can see on the peripheral of my platform.
And these will contribute to the cafe, tables, and seating. So it will actually provide the electricity needed to run the platform. The second device is the trash collection bin, which will lead to the program of the splash playground. So if the bin is functioning properly, there will be water splashing out and kids can play with it. And then the third device is the marine protected zone, which you can see in my underwater level. So we're trying to like foster marine life with this zone. And by doing that, we can lead to the program of a feeding deck. So people can participate in fostering the marine life, as well as a viewing, so a mini aquarium at the bottom where you can look at it, as well as kind of educate coastal communities on biodiversity, ocean waste, and such. And then the fourth program is the bathroom. So yeah, that is my design.
Great. So I think Tracy's question was about visibility, and it seems that you have solved it by attaching a tank where you purify water. Is that correct?
I think for that is supposed to be like a net. So within this net, we are trying to grow algae and like fish, but it's kind of like sustainable, I'm thinking, because if we want to really foster marine life, we don't want to trap them in there. We want them to grow and then be able to go into the ocean.
I have a comment. So, well, actually, in a conservation point of view, feeding behavior is not really encouraged, as feeding behavior actually leads to quite a lot of problem. Well, too much feeding or feeding inappropriate things actually cause pollution to the outside area. So if it is an aquarium tank, so I guess it's still okay. But then if it's connected to the ocean, then it's definitely not a encouraged behavior. That's one point to note. But yeah, I think somehow that may solve the problem that you might have something to see when you're going down into the ocean, like even if the visibility is low outside and you have something very close by the view. Yep, that's my comment.
Okay, thank you.
But Gordon, could you decide what people feed to the fish? So instead of just telling them like you can throw whatever you want, you could actually tell them, you know, you should feed that on and not that.
Well, I believe like a non-routine feeding, it's very difficult to be sustainable. Like if the feeding is done by tourists, then it's definitely not going to be regular. So so it's I believe it's not really the matter of what is feeding, but the in general point of view, like feeding behavior would not be encouraged in any marine protected area in the world. So that's my comment.
Thank you very much. Okay, then we have Gavin still in the team. Are you able to take control, Gavin?
This is my turn now. Okay. So for the visual design, I thought it would be more, so I'm looking at mainly at the Seabin device. It's actually a reference taken from the project by Australian scientists. It's called Seabin project. So I thought it would be more feasible to work on a mechanism that is already working and exists in the world, and I'll make my own modifications to it. The Seabin device is actually basically just sucking in water and captures the rubbish floating on the ocean surface and pumps out clean water at the bottom. So this is the overview of my design that is based on that project, excluding the boat. It is technically an enlarged Seabin device, and this is the layout of the platform. So first layer of the platform is the surface viewing deck. It allows people to do various activities on it, for example, fishing, sunbathing, chilling, having a drink. And layer 2 is inaccessible. It's basically the containers filled with air or other lighter gas that allows the whole platform to float. Layer 3 is the underwater ring viewing deck that has viewing glass on both sides of the ring, so that people can see outside and also see inside. So layer 4, which is on the inner layer, is actually the Seabin device, enlarged Seabin device itself, with a net on the outside to temporarily collect all the trash that it collects from the ocean. So the diameter of the platform is around like 15 meters, which is more than enough for a small group of visitors to do various kinds of activities on it. The whole platform is built with wooden planks and simple steel frames and composite plastic sheets for the underwater viewing deck, which is like 2.5 meters tall and 2.5 meters wide. There's not much like headroom or space in there because I'm just trying to limit the weight of the platform. So it's like kind of being in a submarine. You know, those like submarines, no, those boats that has transparent base that allow you to see at the bottom, that's kind of like it. So on the viewing deck, there are like, on the top surface viewing deck, there are openings in between the containers that allow the visitors to see directly at the ocean surface and see all the rubbish that is being sucked in on the ocean surface. It's simply like floating on the surface, so it can be dragged by a boat to wherever we want. When you decide to stop at this desired location, and then you just drop the anchor. And also have like water turbines that help like generate extra electricity for the Siemens device, but the device itself will have its own power supply. So I want my platform to behave more as an educational device that shows the visitor what kind of impact rubbish has on the ocean. So for the underwater viewing ring deck, there's actually there's transparent composite plastic on both sides of the ring, outside and inside. So on one side, you're looking out into the ocean and see the marine ecosystem. And behind is all the trash that is actually destroying the ecosystem. So you have like two sides, like good and bad. And that is basically my design. Thank you.
My first impression that this is a fundraising wet dream. This is perfect for fundraising money for a nonprofit that collects waste. You can show like the clean outside and then the like dirty inside. Questions and feedback or?
Yeah, definitely that will be a very good fundraising campaign. And well, I think it is a very innovative tool as a monitoring tool on how much marine litter is available. It's in our ocean, because right now we're still lacking of a easy to use, user-friendly monitoring tool of marine litter. Now we're still doing some very manual survey in the ocean or the beach to monitor the situation of marine litter in the world. But with this kind of gigantic device, and I guess that possibly that may help save us a lot of manpower and time to monitor the situation of our ocean. I think it's a very good design and also an education campaign, and it also actually works. So I think it's good.
Thank you.
Can I? Oh,
yes,
sorry.
Yeah, go ahead.
So the boat's there to ferry people from
for transportation only. It's not
Okay,
part of the design. But then like that kind of boat can drag this platform around as well.
Okay, and with the rubbish, I was writing when you were speaking, and I might have missed this. But is the aim to get the surface rubbish and sort of funnel that down into the nets? Is that the concept?
Yep. So like in this drawing, like you see the line. Oh, sorry, I didn't indicate the sea level. There's the line that goes across. So all the rubbish on the sea level, because like most rubbish like floats on the sea surface, actually floats like through like the platform and then go down in the middle. So it's like a pump that a tube pump that pumps in water from the surface down to the ocean, and then like all the rubbish is like filtered through these nets. So you get clean water out, and then like all the trash is trapped in the net.
How would you use such a structure, Tracy? If they told you, hey, we have a couple of million Hong Kong dollars and we build this for you, how would you use it?
I think.
Sorry.
No, please, this is a question for Tracy. Yeah.
Okay, no, absolutely. I think it would be fantastic getting people out onto the sea and seeing the problem firsthand, being able to understand the relationship between ecosystems as well. I mean, one of the things that we found most valuable was getting people to look at the microscopic life in the sea and just getting that connection with the food chain, with the living ocean system, and how we need to protect it. So I think, yeah, this would be fabulous.
It's always a circular thing. Like we need to fundraise to build this kind of structure, but then this would be a perfect thing to fundraise with.
Yes.
Well, I have a suggestion for you. So, because right now we always talked about reduction and source. So see if you can come up with any idea that can help solving the plastic pollution or marine litter problem by introducing this kind of topic in your design. Yeah.
Wait, sorry, I don't really understand the question.
So I mean, what I mean is your device right now can only show the problem.
Yeah.
So my comment is, can you also show the solution in your device?
Right.
But that leads to your creativity.
I'll look into it because right now, because like, it's just sucking on the plastic, but then how to stop the people from actually littering, like that is actually kind of hard to do at the right now for this platform. Because
Yeah.
only seeing the aftermath of it instead of like beforehand, if you know what I mean.
Yeah, but that's it's going to be challenging, but that's going to be minimal as that's everyone is doing it right now. Everyone is trying their best to doing it right now.
Yeah, yeah. Okay.
Thank you very much.
Thank you.
The next group is a one-person group, I think, as well. It's Maximilian Kaufman.
Yes.
Yep. Floor is yours.
Okay.
You want to mention that you work on tourism, yeah? You want to...
Yes. So sorry. So I work on tourism. Can everybody see the presentation? Okay. And so I started with researching what are the actual impacts on tourism. And one of the biggest ones is the toxic sunscreen, of which 14,000 tons end up in the ocean every year, and up to 82,000 different chemicals can be found in the ocean, which can be then traced back to sunscreen. The solution for that is already available, which is biodegradable sunscreen, and there's already some countries starting to ban the sale of normal sunscreen. And even though it's kind of hard to trace how many % of the 8 million tons of plastic that ends up in the ocean every year are generated by tourists, it's generally known that tourists use a lot of single-use plastic, like for example straws and plastic bottles. But nevertheless, tourism offers a great possibility to actually make people aware of their impacts, because normally if they do tourism on the ocean, they are there where the impact happens. Tourism developments also tear down a lot of mangrove forests and coral reefs, and these are natural erosion protections. So tourism developments can accelerate erosion, and also are prone to flooding themselves. Another problem is coral bleaching, which is not directly related to tourism, more generally to global warming, because it happens with the water temperature rises over 30.5 degrees, and the coral expels all the algae from its tissue. It's not immediately dead, but it's like very weak. And if, for example, tourists then damages this coral, it's very likely to die. And therefore, bays and coral reefs are especially vulnerable to over-tourism. And countries that are dependent on tourism oftentimes don't close or like protect the bays enough. And then I did an interview where with a geographer from HKU, and she suggested taxes and other measures to deterrence measures to prevent over-tourism, and also pointed out the Seafood Watch program by the Monterey Bay Aquarium as a good example, which is kind of a guide on what to eat and what not to eat. I then went on to research a specific site, which is Maya Bay. It's become famous in the 2000s because of a movie with Leonardo DiCaprio. And you already see like a lot of boats and tourists. In 2008, 171 people were visiting Maya Bay daily, and in 2017 that rose to 3,520. So you can see by the dots that's already an unsustainable amount. And then you see a lot of rubbish ended up, and plastic straws and dead coral. So they closed it down. You can see the dotted line here. So there's actually a bow line tied here where you can't enter anymore. And they started planting coral and also cleaned up the rubbish. I'll be done in around 10 seconds. So some coral recovered naturally, some need coral nursery, but it only shows a part of the problem of Thailand, because in 1 decade, the coral reef damage went from 30 to 77%, and they mostly blame hotels and water waste dumped in as the main cause for that. So my design concept is to kind of counter two things. First, the over-tourism itself, so kind of prevent that too many people actually enter the site, and also monitor the relationship on what's the noise, what's the water quality, the plastic pollution, and the marine life health, as well as the coral reef health, and how can we correlate that. And I have like kind of two different ways to achieve that. The first is the quantitative data together on how many people are actually visiting the site. There's already a lot of apps who use this kind of data like Google Maps and stuff, but I don't know how easy or hard it will be to actually access the data. And as I'm not a data scientist, I then put my focus on the development of the miniature marine lab. And my first idea was to kind of do a reef, like a camera to actually check the coral reef plastic pollution I felt on the lab itself, but then found it difficult to move the whole thing. So I decided in the next step to use this so-called swarm diver. It's produced by a company called Aquabotics, which is normally remotely, so it has a battery pack and antennas, but I would connect it back to the buoy and have like kind of an extended arm to actually check on different issues, which but then leave this kind of anchored back in place. So the main idea would be to have a water lab inside of this buoy, also sound sensors to detect any like how loud actually boats that bring the tourists in and out or the tourists themselves are, and the swarm diver. And for the swarm diver, the difficulty will be because in my plan, it has a lot of uses. On the one hand, it should check on coral reef and the decay or the health of the coral reef, as well as the plastic pollution and the marine life health. So there might be need for like more than one, which each one having this only one like one thing to do. The way this should work is with a camera in the swarm diver, which can then be the dream would be to write software that can then analyze this data automatically and try to show the changes of, for example, marine life health. And for example, of Maya Bay, it's now been closed for 1.5 years, and there's already like 50-60 sharks in the bay, which actually use the bay to hatch the young ones, because it's now very quiet and they actually have space there. So it shows, and what my goal is to kind of monitor better and to estimate how many tourists for a site are actually bearable for nature. Because the data that is gathered right now is still very like general, and it has to be gathered by actually on pollution, for example, is very easy, very hard to gather data, because you normally have to do it by looking at the beach yourself.
Thank you. So I have a clarifying question. The first maybe because I think you said it, but you didn't like state it. So basically, like it would be one app per beach, and so the app would be connected to this particular device. So is that how it works?
Sorry, I didn't clarify that enough, I think. So the idea would be to create those heat maps and also a rating. So the heat map is generated by the quantitative data to see how many people actually are there. And the rating is generated by the lab to see how is the health of the ocean at that space. And then use one app to like show the map and the ratings of the different places.
Yes. Okay. Thank you.
My comment is that I am not quite sure is the quantity of tourists is the only factor that would affect the ocean's condition, because the quality of your tours actually matters too. So assuming like because it's not the tourists that actually damage the ocean, but the behavior of the tourists damage the ocean. So it would be better if you have methods to monitor tourist behavior. For example, the use of sunscreen actually has a very significant effect to coral growth. Well, but I haven't come up with a solution to how to monitor this kind of stuff. But yeah, that would be more representative to generate a useful data.
Yeah, that's definitely true. And I think all this would also work without the heat map. So if we just have the rating of the water quality, I think that would also be a great start. And as you said, it's not like, yeah, there's tourists which behave and there are tourists which do not. So yeah, the quantitative data doesn't take into account that.
Thank you very much.
Thank you.
Thanks a lot. And then we have one more, and I think this is the last one, isn't it? Maxwell Lau. Or did I miss somebody in the group?
Yeah, I'm Kelvin.
Okay, Kelvin.
Yeah, I'm also in Maxwell's group.
Okay, perfect. So Kelvin and Maxwell. All right. So it's rolling. The floor is yours.
So, okay, I'll share the file first. So yeah, we're starting now. Okay, so my name is Kelvin, and I'm partnering with Maxwell, and we are presenting on our research. So,
so your group is about environmental activists.
Yeah, we are a group in environmental activists and also NGO. So maybe we should like to thank you, Tracy, and also Lydia and Francis from WWF, and which joining our discussion, also all other guests here. So first, I would like to present to you the research results. We have been through the interviews, we have drawn such a diagram to show the relationship of how to deal with the ocean debris problem, in which we involve three main stakeholders, which are the government, the industry and business, and also the general public, in which the government is actually taking a leading role, shall be, but then they didn't right now, because they have very few insufficient regulation policies and other stuff to support the whole oceanic problem here. So that in this diagram, we would like to show that our floating marine laboratory is acting like a medium here to engage with the all problems, like how the device should raise the public awareness, give them education on the issue of domestic waste, and also proposing a feasible business model for the industry so that they could participate or engage in this kind of ocean debris problem. And also we would like the device to gather data about the ocean debris that we are collected, and then so as to give an analysis to the government so as to propose an effective measure for them to be implemented in the society so as to contribute to the problem. And also we'd like to experiment how the mechanics of waste collection would be done through doing this floating marine laboratory. So we have studied a few projects. I will just go through in short. So it is the Ocean Cleanup Project, in which they uses the three elements, like the floating barrier, winds and wave, and collect the marine debris, and also this using a turbine, and also the conveyor belts, the trash wheel, and also the C-beam project, which other colleagues have mentioned. Yeah, and I go through the concept part.
And we actually have a group design concept. We were thinking about using simple mechanics. We try to follow nature. We could be more sustainable when engaging with the environment and cost saving. So we didn't use kinetic approach. Next page. Yeah, we would like the design benefits from problems like sea level rise, typhoon or tidal surges by passively collecting and filtering the debris on the ocean. Next page. After that, we put it back and help removal from the water, and possibly we could like to
be. The image is frozen, so we don't see you going through your.
Yeah, is it?
Yeah.
Okay.
We'll talk. Yeah, finish right away. So we put it back and help removal from the water, and then possibly could build something now of debris to address awareness among people towards plastics. So maybe we'll jump towards individual design?
So yeah, we from the image here, we are showing the proposed location, which is Mawan, which is a very the water current is very fierce here, so that the debris would flow very frequently, like in this flow here. So we propose the location is like the circle over here. Yeah, and also there's some other functions that are clustering in the Mawan, so that I think this is a good location for the marine laboratory to be held to address the issue that we proposed in the first diagram. And this is a study about the mesh size that we have done. So by using different size of mesh, we are proposing to like filter different types of or different sizes of marine debris that is going onto our shore. So I'll talk about the first iteration, which is like a static, more like a boat structure, in which the structure holds up by the buoyants over here, and then perpendicular to the shore here, so that the debris come over in this direction, and then the device would collect those debris, and then so that when we retrieve the debris from the device, we are trying to have like a swimmer to detach one block by one block, and then pushing back them onto the shore, so that we could analyze which types of plastic we have, which types of debris, the size, the buoyancy of those, etc. So this is the section and showing the dimension and how we divide the device into three like scales. So we have different meshes to correspond to different size of debris, like 260 and auto 1. And then for the buoyancy, you would like to have like a barrels maybe to make the device floating. Yeah.
Are we moving on to the comments part,
or we go through the both first?
Maybe we can go through both first.
No. Sorry. If you have different design, it's better that you have a comments after.
Okay.
Oh, sure. Then I will move back onto my slides there.
Yeah. So comments for the. So what is the benefit? I mean, what you want to do is to save time by sorting the plastic by different sizes. Is that the main benefit of having gauges?
Yeah, I think by sorting out, it's this type of, yeah, I think it's like the issue of efficiency, but then it's also about to like more in more detail, like because there is maybe clustering in a very like a big cluster, so that you separate them, you need time, so that it gives the function of like dividing into parts for the debris. Because for the future expansion, we are thinking like to maybe if this is become a larger architecture, so that the layer could be like increased, like we can add different blocks in between the sides, so that the size will scaling in a descending order, so that they could have a more like a detailed or more precise separation of the debris according to their sizes.
I see Tracy is squinting and maybe look a bit incredulous. So what do you think? How could you use this device, Tracy? Oh, you are muted. Let me. You want to unmute?
Can you just go forward to the next slide with the swimmer just going around?
Okay. I think this one. You mean this one?
Yeah. So is the I'm just trying to understand the different sizes where they are in relation. I mean, I'm just you know, a lot of the rubbish is very big, so would it clog up one or all of the sides, and just using a swimmer to move the blocks around? You know, if it is very full of rubbish, that's going to be very heavy, and just different. I mean, just getting somebody to do that's a bit of a job in itself.
Because from the very beginning, we are thinking in my iteration is like about to use a more passive way, like without using like any electricity, and also like kind of other devices where it's high tech, to just use simple mechanics to like collect debris. So I use this approach, but then will be a great problem when it comes to a very heavy, like cluster of debris here. So maybe I'll figure it out, like using different mechanics, like in collection, maybe. So maybe I'll go to Maxwell's slides so that you can do your presentation.
Yes, just an add-on from Catherine's. Maybe the future of the prototype can be developed like into architectural scale. There will be more layers, and somehow the passively collected plastic could also be reviewed by the architecture, and then address the awareness among people towards plastics. And so my concept is actually, we have the same concept, but then different approach. It borrows from the opening of an umbrella. An umbrella cloth could be our mesh, and when it begins to fold, the plastic can be trapped and prevented from washing back to the ocean. So next page. So I also adopt the same size of mesh with catheters, 1 mm, 60, and 200 mm. So there are 3 1 mm beds for the collected debris to stay. And there are 2 kinds of rope. The one in red is shorter. It allows the device to be relatively fixed on water by connecting it to a stone or something solid onshore. And another one is blue. There are longer ones as from the frame there. It explains how the umbrella movement works. So when the blue rope is pulled, there is mechanical connection to make the ribs of the umbrella folds. And the device, next page, is around 1.2 meter times 1 meter. So the water bottles will give some kind of buoyancy to the device. And I intend to use recycled bottles. So this diagram shows how it is folded. So before pulling the device, which is full of debris back, it is better to fold it to prevent the debris to be washed back in journey to the shore. So next page. So as you can see, it is folded, and then the plastic could be prevented from being washed back and then being pulled back to the shore afterwards. So that's all. Thank you.
I'll just go through this line.
So my first impression is that your design and the design, I think, with the person who's interested in the mangrove, were the 2 kind of like more organic design. So it's good to see there's some diversity in the forms as well. What kind of activist or environmental group do you think would be using those structure of this object? And do you think they'll be using one or many of them to form like an architecture?
Yeah, I think for this device, it could be the first prototype to test out how the plastic or debris are passively collected. And we chose Mawan, of course, because it has the highest water current. And I think the site is very seasonal based, because in this seasons, like in March, the water current is likely, Mawan is likely the place for the water current outflow and inflow in between mainland China and Hong Kong. And this served to be the first prototype, and then it could be put into more places to test out and then collect plastic or debris passively. And at the end, if it's successful, it could be to be more modified and developed into architecture, a bigger scale, which I imagine it to be horrific, because we will see different kinds of nasty plastics, which somehow, if it is built into architecture scale, the scale and the debris will be horrific, and to raise awareness of among the citizens towards plastic, especially when the device or architecture is built near the residents, like Mawan.
Yep. Are there questions from other people?
I just wanted to ask a quick question. Bringing the floating umbrella back into shore to empty it, is that again without the use of machines or some sort of pulley system? Is it relying on people to drag it in. My only concern is, again, same as before, just the weight of the plastics and the small size of the mesh. When you're bringing it in, it could be very, very heavy.
That's true, thanks. So maybe next step we'll think of some mechanical procedures to actually allows the device to be pulled back to the shore instead of using mainly only human power. So that will save some human resources and develop a system towards pulling it back.
Okay.
I believe such device, well, I believe your design, and if you are choosing Mawan, such a strong current place to put your device, then you have to consider whether your device actually, or your station can actually withstand that strong current. The water current is really strong that it can tear your mesh. So this is one thing to concern. And on the other hand, I believe it's better if you can develop some kind of automated trash removal system from the station, because somehow you collected it, you still have to remove it. So if you're going to place your station in that place for a long period of time, then your station will get full and heavy. So, and eventually somehow you have to clean it, and better if you have some ways to clean your device easily.
Yeah, thank you.
We'll think about it. Yeah, thanks.
Great. So if you can stop sharing your screen.
Yeah.
Okay, so we're already a bit over time. I think we're 15 minutes over time. I don't want to hold especially our guests who are taking a lot of their precious time. Just want to kind of make some of just to have a bit of the closing remarks. So the idea, I just want to reposition where we are in the process. So now we have each person has presented their ideas. The next step for us is that we're going to be collecting the best of each of the ideas, if possible. And the idea is to eventually, concentrate the best ideas into one, a bit like we concentrate the plastic. we will go towards like one idea that we can actually build. So within this perspective, I'd like to have maybe just a few impressions from our guests. So maybe Tracy, what was your impression overall of the concept that were presented today? And thanks so much for spending all the time with us. You are muted.
Okay, I mean, it's a lot of incredible ideas and really different perspectives of looking at ocean conservation from a whole different manner of needs. I think one of the best things to come out of this will be when you're coming together to consolidate a single design is from all the comments that you've got from each of your individual projects. I mean, it's really hard. There's so many overwhelmed at the moment with the different concepts. But I think, yeah, I don't know how to summarize it effectively, but just looking at the pros and cons of each of your ideas and how you can bring that forward to working on one project. But I think having different stakeholders needs to be met. I think that's a really good way of looking at how can you bring the most people in to get the most impact. I don't know if that was helpful at all.
So a question. So if we want to test, for example, a device that's focused on plastic pollution, do you think it'd be possible to put something in the water in DB, for example? Like, do you know who would need to get permissions from? Or if you don't have the answer right now, would we be able to reach out to you and ask you this kind of question?
Oh, absolutely. Yes. I think, I mean, Hong Kong has its different challenges in different areas, and certainly DB is, well, actually the waters, it's Hong Kong waters, it's not Discovery Bay management. So in some ways that is quite good. I think having something in the water that you can move around to different areas easily, because different times of the year, there's different problems, different current flows. I think absolutely having one thing that you can move around is more beneficial than having something that's stagnant in the different areas. And that, I think, goes to for all of the looking at the algal blooms. Different times of the year happen in different places. So yes, mobility, I think, is one of the most essential things.
Thank you very much. Somebody else who was an attendee who would like to share how they felt about the ideas. Maybe there's one idea that they really love. For example, I see we have, I just look in the order, Daryl. So what was your general impression, Daryl?
Well, general impression was just some fabulous designs. I'm always impressed by this kind of high level work like this too. And I would, for just some feedback, I would echo a lot of what Tracy said too, that, and like within that design thinking, just keep going back into the people that you've met and people you can connect with and the stakeholders, and try and refine your ideas and your designs, because it gets really complex. And that's why you need a small community of experts to help you with these things too. But overall, really just impressive work, and of course, commendable work that you're doing here too. And I think some good feedback from some of the audience members today too. But I really enjoyed being this. So thank you to all the teams and individuals working on these projects.
If we get something on the water, do you think with the adult supervision and making sure that it's safe, do you think that we could engage some of your students to actually come and play with the platform or test it or be like kind of testers of it? Do you think you have some students eager?
I'd love to try and make that happen, because we teach design in the school too, and so like just to see it from a design element too, but also from a science or a data collection element too, or just a community connection element too. It'd be great if we could participate in some way. So we'll keep in touch, Caesar, about it and see what we can do.
Great.
On this, if I can give a, so yes, because at the school we have a marine center with the marine animals, and we teach about the ocean. So it would be great if we could also collaborate, and maybe the students who did this beautiful project, they can come and visit the school. Although now it's not possible because of the virus, but when the situation will get better, I'm sure they will like it. And then we also did a project with our students about building artificial reefs to place in the water. So it would be great if your students could give us suggestions on how to do to build the best prototype.
So what you say is that you want the students to participate in the creation, so you want them to join early, or do you rather have them join later and bring their piece?
Well, we already did because we had this theme week during before Christmas, and the students actually built their own artificial reef, but it was just we only had one day because at that time there was the protest going on. So it would be great if next time we want to do this project with our students, then maybe your students could come in at the beginning to give ideas, or even help them to develop these artificial structures.
Wonderful. If you have some documentation of the things that you have done with your students, if you can share them in the chat, then
we do. Yeah, I can share with you.
That'd be great. Thank you so much. Then we have also Keith. So Keith worked in maritime engineering in Australia for many years and built large ships. So Keith, what was your impression? Are you there, Keith?
Oh, pretty impressive. All the young people design is quite interesting. Also, they mentioned about Hong Kong's slightly different because the July, August, they do have a typhoon and cyclone, and hopefully they have built up some things to understanding the bad weathers and how they can protect it. And also the design they talked about, they're using aluminum, and also they are using a CNC machine to build. As far as I can understanding, aluminum advantage is the lightweight and the cost expensive. And also the corrosion resistant problems on aluminum. So when they design, finally, maybe they have to consider something like a fiberglass or carbon fiber, something like that. Thank you.
Thank you. And then Gordon, thank you so much for all your questions. That was super helpful to have your critical perspective. Do you have closing comments?
Caesar, I have some feedback.
Please go ahead. Yeah,
Hi.
keep going.
So I think two things. One is looking at the research and the designs that the students came up with, it's quite impressive that the details are, the designs are quite detailed and well thought through, because it's difficult to imagine how you're just doing your research, which could be about the issue that you're trying to address, and then translate it into design, which can be quite scientific and technical. So that's quite impressive. The thing I think I would like the students to keep in mind is that you're proposing a lot of things which will sit on the sea. So in the long run, I mean, like we have traffic on land, what I could visualize is there's going to be this huge traffic on the sea. Everybody is going to try and have, you know, different stations and grow fisheries. So how will we create an ecosystem that can exist? You don't want to kind of overcrowd the sea. That's one thing. And also probably there will be some laws around that the government might come up with. So I think that's something you might want to keep in mind, the sustainability aspect of it. Yeah, while you can move your structures around, but there it's going to get busy very fast. So how do we grow it in a sustainable manner? Yeah, thank you. Overall, I think it was really good. I'm excited to see how it takes shape forward.
Thank you.
Thank you.
So should I follow up?
Yes, please.
Yeah, so thank you for all of your presentation. I think it is very innovative and very, I really hope to see some of your projects can be happening in the future. I think it's a very good idea to implement conservation or environmental protection ideas into your design, as sustainable development would definitely be a essential way of development of the whole world in near future. And just a little point to note for the groups that involve organisms in their designs, please do consider the environment for your organisms to live. Like what I mean is to live. What I mean is if you're going to keep some fish, you have to provide the environment that the fish can survive. And it is always very difficult to pet something, to be honest. And I think this is a major challenge to incorporate life in an infrastructure design. And also, I would say that platforms on the ocean have a very good opportunity to further develop. We have quite a lot of aquaculture farms in Hong Kong, and a lot of them haven't been changing a lot in the past decades, but there's definitely a lot of potential in it. So look into it, and I hope to see your good work in the future. Does Francis have anything to add?
Frances, would love to hear from you if you have a form like some feedback.
Maybe not.
Okay.
Yeah.
Okay, no worries. Okay, so thank you so much for all the guests. So please, if you have filled up the form, please don't forget to hit the submit button at the very end, because otherwise all the work that you have done, like ticking the boxes, actually it would not reach to us. Unless you submit the form, it doesn't reach us. If you haven't filled everything, it's fine. I made the form to be known, except your name at the beginning, but apart from your name and your email at the beginning, the rest is not mandatory. So even if you have filled it incompletely, don't worry about it. Like if you are not paying attention, if you have to go to the bathroom, or if you're missing somebody, it's okay, because we will have a lot of people that are grading. For the students, it's the same. I will ask you to also grade everybody else, but people in your group and yourself, obviously. You're not going to. So you don't grade yourself and don't grade the people in the other team, but don't people in your same team. But you can evaluate everybody else. So this is it for this session. I'm very, very grateful for all the students that have produced this work, and also for all the guests that have come to share their expertise. This session was recorded, and there's a number of people that also want to look at it because they're in different time zones. So for example, for our European friends in Norway, in France, they wanted to be here, but it was 4 a.m., so it was a bit rough for them. But they're going to look at the video, and they're going to evaluate all the works that are done as well. So I think I will give you the final evaluation early next week. And so like this, we will have a stronger base to build from. Yeah, is there some closing remark from the students as well? Because I gave like a special, do you want to have, I want to give you the last word, so because you're presenting, so I think you should have the last word as well.
Yeah, I think it was, even though in these challenging times, we made, I think, great stuff. And I think it's also thanks to you, Cesar, that everything works so fine and everything still is so organized in these, weird times that we are all working from home. And I think it's really great to see that even though those are the circumstances, there's still a lot of work can be done and a lot of creativity is still in us.
You know, there's a funny thing, like I think people think about the ocean as this very poetic place to like evade. So it's nice to have this like subject and like you're locked in your room and dreaming about the ocean. I mean, all the problems in the ocean, but you know, it's an escape kind of. Anybody else wants to share or? Okay. So the final date for the studio will be May the 22nd. For everybody who's joined this gathering, I would definitely send a follow-up. So if you want to see what we actually built, really the dream is to build something in the water. May 22nd is about 2 months from now. So hopefully, you know, the ban of traveling and the difficulty of going outside will be eased up, and we hope to see you, you know, close to the water. Hopefully, like the feet in the water. Ideally, that'll be the dream. So we hope to see that happen. Thank you so much, everybody, and I wish you a very good weekend. Bye-bye.
Thank you. Bye-bye.
Bye-bye.
Thank you. Bye-bye.
Thank you.
Bye-bye.
Bye. Thank you. Bye.
Thank you. Bye-bye.